I just saw the debug message. Oh! Hey everybody, welcome to another episode of Daily IoT. This is the one that I have been waiting for on this project, besides getting the link working, which is I want to get full end-to-end. I want to get Raspberry Pi, dryer node to Raspberry Pi to the cloud, and at the end of this episode, I want it to send me a text. And so I've put a bunch of the pieces together in separate testing areas. Now I want to try and combine the whole thing, including, I'm not going to use this power supply in the end project, but I want to test even having it coming straight off of line power and not using my old fat power supply. This is the one that I want to use. We've talked about this. It's just a little bit harder to hook up. I want to hopefully put this on a printed circuit board when we're all said and done. So that is the plan for the episode today. See if we can get this thing working end to end. I like the connectors on this, but you put too much pressure and this thing really bends. And I should have kept the green wire. I don't know what I was thinking to ground it. I think it'll still work. That took longer than expected. First of all, don't ever try to strip a wire with a pair of scissors. Just walk upstairs and get your utility knife. I don't know why I did that. But we have got this working. When I turn on the power supply here, when I flip the surge protector on, I get 3.3 volts out of this. So we are good to power our node from AC line power. So good to go there. Now that we have everything ready to go on the node, just flip on the switch, power, it'll simulate the buzzer, end of cycle. I want to talk about the code that I have running on the Raspberry Pi. I decided to go with Python just because the Node.js, I never did figure out why it was being flaky. I don't want to use C++ because of, it's a little bit harder and slower to get going. Python, the RFM69 Python library that I found seems to work just fine. And there's also a great MQTT library that I can run just right out of the box to send our message up to Losant. So let's talk briefly about the code that's running on the Raspberry Pi. The code in its current state is a mess. This is not how I will check it into the GitHub repository and put it out. This is, again, just an end-to-end. I can go up and clean it up later, but let's run through this. Right here we have the settings for the RFM69, the same key, if you remember, that we're using on the Trinket to encrypt packets. Remember, the gateway is node 1 and our network is 100. All things that we went over when we looked at the Trinket code. Up here we're importing MQTT, PAHO MQTT, which will help us get messages up to Losant, and the RFM69 registers in RFM69. Now there are some things that you need to have installed on the Pi, like wiring Pi, and I believe the other one is like an SPI dev, so that we can use SPI through Python. And so I had to install the Python developer tools, and there's a few things to install. I'm not going to go through that because I've already done it on the Raspberry Pi, but there are some prerequisites that need to be installed. I will get that list and post them with the code before this is all done. But once we've set that all up, setting up the RFM69 module is pretty trivial. All we do is we say, we new up an RFM69 here. We're going to specify that it's the 433 megahertz, the node and network numbers. I honestly can't remember what this true does. And we needed to change the interrupt pin to be pin 22 because that's how I hooked it up to my Raspberry Pi. Again, the connections I will post as well. I'll put together a fritzing on those. I do have the high power module, so I'm going to do radio.setHighPowerTrue and radio.encrypt using the key. So all the traffic will be encrypted. The on connect and on message have to do with MQTT. We will come back to that. We're going to skip over it for now. This is all MQTT stuff as well that we'll need when we get to Losant. Ignoring that for just a minute. And then we have our loop here. We're going to put the whole thing in a try so that we can just Control C, which will dump us down into this keyboard interrupt to get out of it. When we do that, we'll call it radio.shutdown, so it will gracefully shut down the RFM69 module. But while true, we're just going to loop forever. We're going to do a radio.receiveBegin to wait for traffic from the RFM69 module. And then while not receive done, so while we haven't finished receiving an entire packet, just sleep and keep looping forever. And then we'll finally come down, and once we bust out of that while, it's because the packet is finished transmitting. And then this long line of code here is basically taking the data, which is just an array of bytes, and turning those into characters and concatenating them all together to form a string. Remember that I'm sending that as a JSON packet that is the topic and message to send to Losant. So we're going to do a JSON.loadString on that to get it into a dictionary. So at this point, I print out that dictionary. That was part of my debugging. I'm going to send an acknowledgement signal, and then this again is MQTT. So at this point, really right here at code, right here, this print data, we have the packet from the dryer node, and it's ready to be sent over MQTT up to the Losant broker. And now that we have the RFM69 communication working between the node and the Raspberry Pi, it's time to forward this stuff up to the cloud. And you remember I said we're going to use Losant for this, and Losant has a built-in MQTT broker. Now, as this is not a polished tutorial, I am really just going to do this real time. And so don't expect this to be a polished how-to. We're going to just straight log in and build this thing right in front of you. So this fridge watcher is a project that I did before. What we do when we log into Losant, there's a lot of different terms and building blocks, but we want to start by building a new application. So we're going to go create application and give it a name, call it home automation, and we don't need to give it a description. We'll create. Okay, now we have things in our application. We have devices, workflows, events, security, experience, all this stuff. We don't need all of it to get up and running because MQTT is supported out of the box in Losant. But what we do need to do, and what all of the Losant flow is going to be based off of, is having a device. And now this device is going to represent our gateway that is the Raspberry Pi. And so we're going to hit create new device here. I'm going to create it from scratch. Device name, we're going to call it MQTT. Let's just call it the home gateway. And we'll skip the description. It's just a standalone device. It says gateway here, and you might think, oh, but Kevin, it's a gateway. This is gateway devices connect directly to Losant and can report state for themselves, or devices of type peripheral, which we're not going to get into. We just want to do standalone. Just trust me on that for now. We'll hit. We don't want to add any device attributes or tags at the moment, and we're just going to go ahead and hit create device. And there we have it, home gateway. Now, our gateway has a specific ID in Losant, and we're going to need that because that is the MQTT client ID that we're going to need in our library. So when we come back over to our code here, when we set up our client, our MQTT client, we need to put that in as our client ID. So I'm going to go ahead and put that in there, then come back over to Losant. Now that we have our device set up and configured in Losant, we need a way to connect the physical device to what I'm calling in the Losant cloud the virtual device, which we just created. And to do that, we're going to use the MQTT broker, but we have to authenticate with the broker with a username and password. And the way that works in Losant is we come over to the security tab, and we need to create an access key. So I'm going to click add access key. And once we create this, you'll see the following values cannot be changed after key creation. I want this to, I don't want to have any restrictions on it, not restricted to specific devices. I'm going to leave all devices, and I'm going to click create access key. Now it's going to give me an access key and an access secret, and I cannot recover these after I close this window. So what I recommend is to download to file. It's going to download that right there. You can open that up, and you can see I've got my access key and my access secret. And I like how they have this, I have copied my access key and secret to a safe place. You can't just click close window by accident. You have to make a conscious step of, I've got it, don't worry, and now I can close the window. Okay, so I've got my access key. The access key is the username, the access secret is the password. So again, I'm gonna copy the access key out of there, and where's my window? Right there. That's going to be, I've got this client.username password set. The first argument is the username, which is the key, and then the secret is the password. So put that in there like that. And then I've got client.connect, and we put in broker.losant.com. It's going over port 1883, and the timeout is 60 seconds. So the keep alive for the MQTT broker client connection is 60 seconds. If you don't report in after that long, it's going to consider you disconnected. And so then the Paho MQTT library has this loop start, which creates a separate thread which manages that MQTT connection for you. Make sure that it's kept alive and is negotiating with the broker. And so these really, this is boilerplate code up here. The on connect and on message is just callbacks to print information when you connect to the broker and when you receive a message from the broker. We won't actually receive any messages from the broker. We're just sending messages. And then this is it, just 6 lines of code here is all we need to do to stand up the MQTT piece. All right, the only piece left for the MQTT interaction is to publish an event to publish a message on a topic to the MQTT broker. And we do that by doing client.publish. And remember, my JSON that I'm sending from the dryer node has a topic member, which is the topic we want to post to, and the message that we want to post to it. So that's it. Just that single line of code is what will take the message from our dryer node and push it up to the Losant broker. We'll save that and transfer it over to the Pi. Now that I have the code over on the Raspberry Pi, I'm going to open up a terminal window. I have SSH'd into my Raspberry Pi, and let's CD down into the folder here, just to show you the files that I have here. I've got my gateway.py, which had the code that we went over. The rest of these files are from the GitHub repository for the Python RFM69 module. And so I didn't write the code for any of these. I didn't change any of it. And sorry, it's actually just the 2 Py files. The PyC are the compiled versions. And so just these 2 other Python files are all that you need to pull down from the repository, and then our gateway.py. And so what I'm going to do, we'll put this down here, kind of split screen it here a little bit. I'm going to come back over to the main page here. You see the home gateway is disconnected, and then there's, at the bottom of this screen, there's a communication log. And what I am going to do over here is just run my gateway.py. You have to run it as sudo so that it can access the SPI bus. So we'll say sudo python gateway.py. As soon as we run this, connected with result code 0, and you can see that we have authentication succeeded and connection succeeded. So just like that, we are connected to Losant. Just copy a few keys, IDs, and a little bit of code, and we have a connection between our Raspberry Pi and the Losant cloud, which is really cool because there's a lot of stuff that we can do. But just to show you briefly, if I hit Control-C here to end, you see we get a graceful disconnect. It says home gateway disconnected from Losant, connection closed. And so that is all working. Now I'm going to run it again. It will reconnect. So now if everything goes correctly, when I flip the switch here, my Trinket will send the JSON packet over to my Raspberry Pi, which will dissect it and grab the topic and message and forward that on to Losant, and we should see it in the communication log. So let's see what happens. I haven't tested this. Oh man, look at that. Oh, I love it when a plan comes together. Look at this. Okay, so we got the logging here. This is the packet that I sent from the Trinket. You can see it's this JSON formatted here. The topic is home, upstairs, laundry, dryer, state, and the message is done. So we're saying that the dryer cycle's done. And right here in the communication log, we got an MQTT message, home, upstairs, laundry, dryer, state. And if we, let's see what happens if we, okay, look at that. And then it shows the message that you sent, which was done. All right, so now that we have the message, we can build a workflow around it. And that's the most powerful thing about using Losant. And so if we go to, we got a menu here because we're collapsed. Let's go to workflows, and let's add a workflow. And we'll call this the texting dryer workflow. I mean, that's what we're dealing with here. I'm not big on descriptions, as you may have noticed. Okay, I'm gonna put this back out here. All right, now, again, I will do a more in-depth episode on Losant and how all this stuff works, but the quick version of this, and to keep this video from going too long, is we need to grab some sort of input to start our workflow, and that we can base the rest of the workflow off of. And in our case, it's an MQTT message. So you see we have triggers over here. I'm gonna grab the MQTT trigger, drop it onto the workspace, and we need to pick a broker. We're just gonna use the Losant broker because that's where we're sending it. And the topic was home / upstairs / laundry dryer state was the topic that we're publishing to. And that's it. We have our trigger set up, and then what we can do is we have outputs down here. We can grab the debug node and we just connect them. I mean, this is graphical programming. And the message, optional message, I think it will just flow straight out. I think that's all we have to do, actually. And then there's a little debug section over here, and no debug logs yet. So what I'm going to do is I'm going to turn off my node, my dryer node, and then I'll turn it back on to simulate another end of cycle. And so let's go ahead and turn that back on and see if this works. Takes a couple seconds. Oh, I didn't get anything. Dang it. Let's look at the terminal. Okay, it did send another topic, home, upstairs, laundry, dryer, state. So I'm missing something. What am I missing? I'm a dummy. It's late. We have to deploy the workflow. So let's deploy it. Workflow saved and deployed. I thought I was going crazy there for a minute. Okay, now it's actually applying. Let's turn this thing back on. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Oh, look at that. Right at the 5 second, I don't know if I was really doing the seconds, but anyway, look at this. This is working. MQTT is feeding into the debug node and outputting it right here. So we know that the whole cycle is working. We're going all the way from the dryer node up through to the Pi, up to Losant. Amazing. Now, watch how simple this is going to be to send me a text message. You come down here to outputs. There's lots of different things. You can change device state, Google PubSub, HTTP, but what we want, Slack, I mean, it's got a Slack integration. How crazy is that? Email, SMS is what we want. Basic SMS message. And so I'm going to drag it over here and connect it. Email, sorry, the label is going to be text me. Define the phone number in the body of the SMS message. All right, let's phone number it up here. Your dryer has finished. Looking back at the workflow, we've got the input, the trigger MQTT, and now it's going to feed into both the debug and the SMS. We're going to hit deploy workflow. And you know what? I'm not even going to test it. I'm going to move my camera and we're going to try and test it. All right, let's test it. I'm going to turn it on. I just saw the topic published to the Pi. I just saw the debug message. Oh! How cool was that? Like, that was awesome. I don't know how long that took me. I'll have to go back and look at the timestamps, but I feel like an hour and a half, connected up, built the Losant workflow, got the code. I'd already written the code for the Pi, but just added the key, the security keys and stuff like that, and copied it over. But pretty good. Worked like a champ. And so that's it. That's the full. Got in the background here. We have successfully gone from dryer all the way to cell phone. I mean, it's not in the dryer, I get it. But using the power supply mainline, simulating about a 5-second burst, it takes about 4 seconds. So I think we got about 1 second of overhead. So the buzzer should be enough power for long enough to get us through all this. Now that it's all working, next step is to stick it in the dryer. And that is it. That's going to close us out for the week. I'm going to clean up the code on this over the weekend, so I should be able to have that posted so that people can take a look at, you know, the Trinket code, the Raspberry Pi, all that stuff, and have that for you by Monday. That is it for today. Once again, I have turned the camera on and have not thought of a question of the day. It's taken me a long time to think of a question of the day. All right, this is the best I can do. Are there any parts of this entire process system, whatever you want to call it, that we drew up here, that we've built? Is there any part of this that you don't understand? And I don't mean like, how do radio waves work? But is there any piece of this that we built that you're not sure what happened? Let me know down in the comments. I want to make sure I clear up any misunderstandings or confusion so that people can understand what we have going on here. But I appreciate everybody watching. Really exciting episode. I'm glad that you tuned in. I'm sorry it went a little long, but I think we got some really cool stuff accomplished. So thanks again for watching Daily IoT, the show where together we're learning how to make the Internet of Things one day at a time.